Hello, ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today we're going to be talking about our next unit, which is all about stoichiometry. So follow along in your notes, and if you have any questions, please make sure to let me know. The only new term in this entire section is the word stoichiometry. The word stoichiometry just means a process of finding the relative amounts of reactants and products in a chemical reaction. So the way I like to think of it is it's as if you have a recipe and you have to think about how many ingredients do you have and how you can mix them together to make what you want. And of course, that's what stoichiometry is all about. Now, there are two important things that we've been talking about in the last couple of units that are going to come back, and that is the law of conservation of matter. In case you forgot what the law of conservation of matter says, it says matter or mass can't be created or destroyed in a chemical reaction. It's always going to be preserved, and that's the reason why we balance equations. So you can see in this equation, I have a 2 in front of the H2, I have a 2 in front of H2O, and the reason why I put these coefficients here is because I want to have the same amount of stuff on this side of the arrow as I do on this side of the arrow. If I didn't have the 2 here, I wouldn't have the right number of these blue circles, which represent hydrogen, and if I didn't put a 2 over here, I wouldn't have the right number of oxygens, the red circles on the right, and then red circles on the left. That's the law of conservation of matter. Another important thing that we talked about is these coefficients, the 2, the 1, and the 2, form a nice little thing that we like to call a mole ratio. So a 2 to 1 to 2, that is a type of mole ratio. Again, you can think of it as if there are ingredients in a recipe. You have 2 cups of hydrogen and 1 cup of oxygen, and you're able to make from that 2 cups of water. Okay, let's start with the stuff that we've been doing in the last unit. So, can you still convert from grams to moles or from moles to grams? Hopefully you can, but if you can't, use the map to Mole Island and you'll be able to find your way. So how many moles are there in the following? 253 grams of NO2. Now, again, you have a 50-50 shot. Do I need to divide or multiply by molar mass? And so if you look at your map, it says you divide. Where do I get the molar mass of NO2 from? On your periodic table, you can look up nitrogen and you can look up oxygen, and we have 2 of them. And when you add them together, you get 46.02 grams. Notice my grams cancel and I'm left with moles. So in your calculator, do 253 divided by 46.02. When you do that, you get 5.50 moles of NO2. And again, I like to keep whatever substance I'm looking at the end here, just so that you don't lose track of it when you're doing more complicated calculations. What about another one? 12.3 grams of N2O4. Okay, so N2O4, I can find the molar mass. It's exactly just like I did in this one, except it's basically double. So I get 92.04 grams because I have 2 nitrogens and I have 4 oxygens. And again, grams cancel away. I'm left with moles. Plug this into your calculator, 12.3 divided by 92.04, and I get 0.134 moles, again, of N2O4. Don't forget to put that. So hopefully that's a nice refresher in how you convert from grams to moles. Can you do the opposite though? Can you convert from moles back to grams? So what if I have 7.80 moles of CO2? CO2, look up the molar mass and then think about what you have to do. If you're dividing for these ones, you'd be multiplying for these ones. So I'm going to multiply by the molar mass, which is 44.01 grams. And when I cross out my moles, I end up getting 343 grams of CO2. All I did was 7.8 times 44.01. Okay? Last but not least, I have 0.5. I have half a mole of CH4. I can find the molar mass of CH4 by adding everything together on the periodic table. I get 16.04. When I multiply them together, what do I get? I get 8 grams of CH4. So again, this is our last unit that we just did, so hopefully this was a refresher. If you need to pause along the way and go back and see what I was talking about, feel free to do that. Now this is from a little bit longer ago. This is balancing equations. In case you forgot, when we balance equations, I want to make sure I have whatever on the left of my arrow is added up to exactly what the right side of my arrow says. So I have to count all of the elements. How many carbons do I have? How many hydrogens and how many oxygens on this side? So when I do that, I have 5 carbons, I have 12 hydrogens, I have 2 oxygens. Nice and easy. What about on this side? I have 1 carbon, I have 2 hydrogens, and I have 2 plus 1, I have 3 oxygens. So pick something that's really easy to balance. One of the easiest things to balance in this would be just, okay, I have 5 on this side, I don't have 5 on this side. What if I put a 5 here? Now I have 5 carbons, so I've changed that number, and I have 10 oxygens plus 1, that's 11. Okay, I have 11 oxygens now if you're keeping track. What's another thing I can change really easily? Well, if I put a 6 in front of this, now I have 12 hydrogens. And again, I've now changed the amount of oxygens I have. So I have 10 plus 6, I have 16 oxygens on this side. I only have 2 on this side. What number can I put in front of this in order to make 16? I can put 8. And so now I have a completely balanced equation. The numbers now match on both sides, and I followed the law of conservation of matter. The other key thing that we always said whenever we were doing equations like this, what is the mole ratio for this entire equation? So this is a 1 to 8 to 5 to 6 ratio. So please write that down because it's going to become important when we start doing more complicated calculations. All right, again, if you have to pause along the way, feel free. Next up, write the balanced equation for Fe, okay? That's iron and oxygen, so plus O2. And I want to make, that's an arrow, iron 3 oxide. So iron 3 oxide, in case you forgot, is Fe2O3. So again, I want to count everything, okay? I've got 1 iron, I've got 2 oxygens, I've got 2 irons on this side, and I've got 3 oxygens. Now, here's something that, again, if you want to pause and try to do this, feel free. You'll be able to probably figure it out, but I want to show you a little trick. So the trick is, instead of dealing with the easy one, which would be just to put a 2 here, I probably want to deal with this because I can never get a 2 and a 3 to be equal to each other. So think about this. What if I double this? Now I have 6 oxygens. I can definitely make that a 6 if I wanted to. How many irons do I have? Now I have 4 irons. So since I have 6 oxygens on this side, I would put a 3 here. Now I have 6 oxygens on this side. And now again, count your irons. I have 4. I only have 1, so I would need to put a 4. And that's how you would balance this equation. Again, if you need to go back, feel free. But now I have a totally balanced equation. I have 4 irons and 6 oxygens on both sides. Now, think about this. What is the mole ratio for this equation? I've got a 4 to 3 to 2 ratio. And that would be my mole ratio. Again, write it down. All right, last but not least, in case you forgot one of the more difficult types, we're going to now do a balanced equation for this. AlCl3, I have aluminum chloride. It's reacting with potassium carbonate, so plus K2CO3. And I'm making, remember the word make or produce, that's an arrow. I'm making KCl, that's potassium chloride, and Al2CO3, that is very difficult looking aluminum carbonate. Now, I want to count everything I have on both sides. So how many aluminums, chlorines, Ks, and CO3s. Remember, I can make this a unit if it appears on both sides. So I've got 1 Al, 3 Cls, 2 Ks, and I've got 1 CO3 unit. What about on this side? I've got 2 Als, 1 Cl, 1 K, and 3 CO3s. Now, what can I do? Pick something that you want to balance and try to do it on your own if you'd like. All right, I'm going to start, though, by saying I can start really easily with my aluminums. So I have 2 aluminums now, and I have 2 aluminums on this side. How many chlorines do I have? Now I have 6, though. So I want to balance that. I would need to put a 6 over here, but now I have 6 potassium, and I only have 2. So that means I would need to put a 3 here, and now you can see I have 6 potassiums. But what did that do to my carbonates? Well, I have 3 carbonates. I have 3 carbonates. In reality, I already balanced my equation. I have the exact number on this side of my arrow and the exact number on this side of my arrow. One more time, what is the mole ratio for this entire equation? It is a 2 to 3 to 6 to 1, and that is how you would write the mole ratio for that. Okay, so that's pretty much it. You should review how to balance equations. That's something important. And you should also review how to convert from grams to moles or moles to grams, because our next thing that we're going to be doing involves all of those things put together.